Hello, everybody. This is David Hilster from Dissident Science and the CNPS, and you have tuned in to our live Saturday morning science chats. Hey, I want to welcome everybody from my YouTube channel, Dissident Science, and also those in the CNPS, John Chappell Natural Philosophy Society. And today I'm going to be speaking, and I hope you're going to enjoy this because I've been wanting to speak. Actually, the subject came to me a couple of weeks ago when I started realizing when I started hosting these Saturday morning, Saturday in the United States, Saturday afternoon in Europe, and Saturday evening in Asia and Australia. We got people from around the world. I realized that not everybody, even in our own organization, knew what was going on in our organization and what topics are being pursued very rigorously, like James Maxwell's Expanding Earth. I thought, oh my gosh, there's a lot of people who need to know about all the areas and all the scientists that are involved outside the mainstream critical thinkers. So that's what today is about. And so I will be speaking. I hope you enjoy this. We're going to be, of course, I'll be talking in the beginning, and then afterwards we're going to open it up to discussion. So if you are a person who wants to come on live and talk with us, you can do so by going to this. You can talk with us live by going to live.naturalphilosophy.org. You'll get into our green room. We have room for 10 people. So I see we have people already waiting there. But if you want to come on air and chat with me and talk about how everything I'm saying is wrong, which you have the right to, then you can do that. So you can go to us. And of course, we're coming to you live from actually three places: the YouTube channel for the Natural Philosophy Society, the Natural Philosophy, John Chappell Natural Philosophy Society, and we are also going live to my Dissident Science YouTube channel. I want to welcome all our subscribers. That's around over 4,000 subscribers, so I can see people are popping in already. So I want to welcome everybody, and I want to thank you for subscribing to our channels. And you're not going to see anything like this in the world, which is really cool. If you want to visit our websites, for the CNPS, you can go to naturalphilosophy.org. Or if you're more of a layman and want more of a magazine type venue website, you can go to sciencewoke.org. We're going to be looking at that a little bit today. We get quite a lot of views on that because it's more like a magazine for critical thinkers. So today's topic, I tell you, is a fun one. So let's get to it. Yep, that's our stinger there. It's really pretty fun to make those. But yeah, we're going to be talking about that subject coming up. So before that, I always have some slides ahead of the talk. So these are, in fact, our Saturday Science Chats. Believe it or not, they started in 2008. So we've been going 12 years with these, believe it or not. Almost every Saturday, we choose 10 a.m. Eastern time because that fits the globe real well. The Earth expanded a lot, and the Pacific is the biggest expansion. So we have that big extents. Problems thinking the right language here. We have that very vast ocean there, so we make it right now. I think in Perth, it's 12 hours difference, so it's 10 p.m. in Perth, while it's 10 a.m. here on the East Coast, and 7 a.m. for those poor souls on the West Coast. But that gets us all around the world because we do have people listening from all around the world, and I want to thank everybody for tuning in. So let's go forward here. I always talk about this just in case a lot of my Dissident Science subscribers, they're not used to coming to these venues and don't know what the CNPS is all about. I'm a member. I've been a member of this group in one form or another since 1996, to critical thinkers around the world. And just a reminder, this is an organization that above all promotes critical thinking without malice. Our mission is to be an organization that supports, publishes, and promotes serious scientific work outside mainstream science, to provide a forum for open debate about modern topics in physics, cosmology, philosophy, mathematics, etc., and to provide a forum for presenting serious papers and theories without fear of censorship. And most important, to be run and controlled in its entirety by its paid membership, including the election of the directors. And that is very important because we learned that possibly the hard way. If you want to join our community, again, if you're from if you are a subscriber, well, I'm not talking well today. If you are a subscriber of Dissident Science, I welcome you to try to go over to naturalphilosophy.org, sign up, and join in. There's conversations all the time going on about lots of topics. It's a new website, so our 300 some very active members worldwide are finally jumping on and I appreciate all of those members, especially of the CNPS. If you have not signed up, you have to do that. Yes, we have you in your database, those people who have paid, but we have a new system, a new paying system, etc. And of course, if you can pay an annual membership of $35 all the way up to a couple hundred of dollars, we do have people who give us generous donations to keep going. Why do we need generous donations? Because we have a lot of expenses, including around well, I won't say how much, but it's a bunch of money to keep us going for the website, for this service that we're using, StreamYard, and all the software that we use, because today in age, everything is online. So how can you sign up and participate? Well, there's again, a number of ways. Sign up at naturalphilosophy.org. Consider becoming a member. I should just stick to my slides, huh? Participate in the community discussions on our website. Naturalphilosophy.org is the place where we have our new system, which is based on BuddyBoss, and post news and happenings on social media about us so people will find out. Believe it or not, that's the way the world works today. It's not telephones and mimeograph machines. Our websites you can visit as naturalphilosophy.org, as I've mentioned. Our online, that's the community. Our online magazine, sciencewoke.org. We do have a wiki with over 10,000 pages, and you can see that at wiki.naturalphilosophy.org. And yes, we use the exact same software, which is open source, as Wikipedia. And we have coming our Chappell University courses in natural philosophy. We already have 2 people already signed up. Dr. James Maxlow, my father, is going to be talking about a Newtonian universe using the particle model. He's already signed up. And if you're a person, I'd love to get Nick Percival to talk about relativity. If you haven't seen Nick Percival, go to Nick of Time YouTube channel. But if you are a person that wants to communicate, you can even give a course on your own theory so people can sort of learn it in a course-like setting as if you could teach. And we're going to have more courses. I hope to do a course on what I'm talking about today, sort of introductory course to critical thinkers outside the mainstream. So look forward to that coming online in the next year. So why do we support everyone? That's one of the questions we get. Isn't there only one accepted model? This is not my part of my speech. This is, again, just setting us up, our philosophy. Well, the reason is because universities do not do that. If you're a person that has a new model of the universe, go to the physics department and say, I want to rewrite physics. Go see what they say. So we do that, and that's why even with our university. And, of course, change comes from dissent. That's where it comes from. It doesn't come from groupthink. So it's very important. That's why an organization like ours is very important. And CNPS gives a platform and is not from groupthink. So that's really what the Chappell Natural Philosophy Society is about. And of course, in the end, who decides? It isn't you. So if you disagree with something, guess what? It doesn't matter. Who decides is history. It's not the universities even, and it's not the science evangelists out there pushing mainstream theory and laughing about things like Einstein could be wrong, or journalists. So, okay, so let's get into my talk for today. I am going to talk about today's critical thinkers. So, myths about dissidents. there is no consensus. They're all salesmen and no buyers. Well, guess what? If you stay for the end of my talk, I'm going to be talking about 5 theories. I have them in a chart, and 4 of the lines are almost all in agreement. That is what these theories agree with. So the new modern theories, there is a lot of agreement, and that's maybe even shocking to people in our own organization. So dissonance, of course, another myth. Throw out everything and ignore previous theories and models. That's just so far from the truth. It makes no sense for you to come up with a new theory of the universe and you don't describe everything that's there. Obviously, your new model should be describing things that aren't there or giving physicality to things that aren't there. Well, guess what? In the mainstream science and the standard model, that ain't hard to do since we don't have any physicality for light, for magnetism, for electric fields, for even electricity. Current in physics are holes moving backwards. I mean, man. So all of those things, light. So those are, of course, dissonance when they make models. They have to describe everything that's there and then some. And they say, oh, that's what I just said. And new models aren't predicting new findings, and that is not true either. So dissonants all agree on one thing. This is for sure, that physics and cosmology are lost, is a mess. In fact, in my documentary film, Einstein Wrong, I've got I think it was Dr. Cynthia Whitney says, I think it was her, physics is a mess and it's time that we take a look at it. So, all right. Here is a shocking fact, and the reason I'm doing this today is that senior members of the CNPS and the MPA, what it used to be, MPA started in the early 90s, are not familiar with many of the areas of dissident work. And case in point, like I said, is expansion tectonics. I mean, we have people been on this Saturday morning chat that said, I really didn't know about this, or I really haven't thought about it. I'm thinking, what? Let me put it this way. If you don't know about expansion tectonics, and you love physics, doesn't make sense, because expansion tectonics has huge implications on physics. Why? Because expansion tectonics says mass is increasing. That is, the Earth's gaining mass, and it's not from things falling down from the sky and landing space dust. It's gaining mass at a subatomic level, creating atomic structures. That in itself should get you interested in expansion tectonics. But again, I was really shocked to find out. I was like, what? We've been talking about expansion tectonics since the 1990s in the NPA and the CNPS. But we talked a lot about a lot of subjects. I think maybe out of thought, out of mind. But that was pretty shocking to me. But it is an obvious fact that new critical thinkers are not aware of all the areas covered by the critical thinking community. And that's not good. We need to know what other people are doing, because in effect, our own work. People are often isolated in one area because they're working on their own model, and there are people in their own YouTube channels in their own world, and I don't want to talk about see other things. Well, guess what? Other people may be doing things that are going to change history of science, and we already had those things happen. A number of the people we're going to talk about today, in my opinion, have changed science forever. I mean, give Borkert and Infinity as one of them, for instance. This is not good, given most work is interdisciplinary. Yeah, that is, I don't care what you're working on, if you only isolate yourself and don't listen to the other critical thinkers doing other things, someone else is going to come along, think of the same thing you did, and do it better. Or take your stuff, modify it, and do it better. That's happening all the time. My father and I are working on our own model. We're robbing people left and right. And there's a lot of good stuff out there to rob, for sure. The dissonant areas. What are the dissonant areas people are working on? Well, relativity, that's the first one. That's actually what started the MPA, the Natural Philosophy Alliance, which then turned into the Chappell Natural Philosophy Society. The Big Bang, that's also one that these two are very easy to think about on your own and figure out. There's a lot of problems. A lot of problems in cosmology. Redshift, Big Bang's part of that as well. The models for the sun. Plate tectonics, where you have you have all this these continents moving around, and you had Pangea, which doesn't make any sense. How would you have all the land on one side of the Earth? It's not going to happen. If you have water on the Earth and it rotates and there's gravitational field, if you have land all on one side and it's sort of lopsided, it's going to create an island on the other side. Doesn't make sense. So plate tectonics is an area where expansion tectonics is really being replacing plate tectonics. Quantum mechanics. Man, if you talk to people in our group, quantum mechanics are going to shake their head. Quantum mechanics, the way you can think of it, is just the subatomic world. And man, what's going on there is absolutely absurd in mainstream science. So it's an area of dissonance to look at. Structures, something people don't know. In fact, I've been helping a structures group to get together. They have been very active in the MPA and now in the CNPS. They actually have their own group. They're forming their own group, and I'm helping them with their website. Of course, they're part of our group as well, but they have so many people interested in that. Structures, just the way physical things go together. When you put spheres together and they put them all together, like you see the spheres of atomic structure for gold. Go on the internet and look at gold atoms. They're spheres, and they all happen to be look like they're touching each other in hexagonal formation. Is that what's happening in the nucleus of an atom? Is that the same thing that's happening in the nucleus of an atom? So structures, super important. Philosophy, man, people don't understand. Natural philosophy, that's why our group's called Natural Philosophy, because that's looking at the philosophy of nature, the rules of nature, the way nature works. And philosophy itself, you don't know how much of the standard theory, the standard model, it's not a model, but they call it a model, it violates so many rules of philosophy. It's just left and right, Big Bang. Violates so much of many of the rules in philosophy. And mathematics. Mathematics is wrong. Yes. We're going to talk about that. Talk with Peter Erickson and about the square root of a negative number. Negative numbers in general, our real number system isn't necessarily the best. And we're free to think the way you want. I have a bachelor's in mathematics. I love mathematics, but I love Peter Erickson's work. And we're going to talk a little bit about that. Particle physics is such a mess. Here's one. Look, read the book, The Higgs Fake, by Dr. Alexander Unziger, a physicist from England. In fact, Sabine Hossenfelder today put the physicists on the line saying they are making more excuses to try to build a Large Hadron Collider, a bigger one, and they're just trying to do it because it's just a marketing and selling ploy. She just came out with a video about that. She left the Hadron Collider, wrote the book Lost in Math. So particle physics, as Alexander Unziger, I agree with him completely. Throw everything away from 1930 on. Neutrinos, W and Z particles, quarks, get rid of them. We got to start again. We know there's a nucleus. We know there are things going around it, but that's, in my opinion, in many dissidents, that's all we really know for sure. And then, of course, there are new models of the universe, so you want to stick around because that's the last thing I'm going to talk about. And like I said, there's a lot of agreement today on the new models, and not only the people who've been spending the last 2 years talking about charge and moving charges and whether they produce fields and electric fields, magnetic fields, the new models, that all becomes moot. And if you think that's shocking, stay around. All right, who are the dissidents? Who are dissidents? Why are they around? Well, those are people who look for truth without financial or peer pressure. That is, we are human beings. We have our intellect and our brains. No one can tell us what we have to think. We don't go to school in physics and say, okay, tell me what the truth is. These people are people who look to the truth, so they don't have to worry about whether their opinion affects them financially or their peers around them will scoff them and scorn them and banish them. So these are the dissidents, the people who don't normally have financial or peer pressure, because otherwise they're not going to do it. In most cases. People who are retired. Well, why? Because when you're retired, you can say what you want. I know Dr. Ed Dowdy, who says that gravity, in fact, does not bend light. He's from NASA. And he doesn't, that broadcasting that idea and his evidence that he has, which is when you have light go through a corona of a star or a sun, it bends. Yes, stars bend because there's a corona. There's mass in space. You get outside that mass, it doesn't bend, but relativity predicts it does. Well, he said, I'm retiring. I don't know if he's in his late 50s, early 60s, and now he's free to do what he wanted, but he was doing it anyways, which is more of a rarity. People don't have degrees in the area of interest. And this is a big one. I'm going to do a talk one time or a video on dissident science about what does it mean to be an expert today? What does it mean to be a PhD? If I've been studying all these subjects in relativity for 30 years, reading all the same things that you read in college, and then some, and criticisms, what does it mean? What does a PhD mean, right? So people who do not have degrees in an area, but I looked up how to change the board in my dryer that normally I have to pay a person to do. I went to the YouTube, found the part, bought it, knew how to put it in. Am I an expert at fixing dryers? Well, if I keep studying, I could be. So we have to get away from that. And of course, most are dissidents and are heterogeneous. Well, what does that mean about most dissidents are heterogeneous? I'm sorry, take away that R there. Put these together last night. So most dissidents are heterogeneous, meaning you're not going to have agreement amongst the dissidents. We don't all have one model. There are people who say there should be charge as a fundamental attribute in the universe, and there are people that say that there isn't. There are people who say that light is waves in ether, and there are people like my father and I who says, no, it's not. They're particles and flowing in waves of particles. So again, we are not a homogeneous group of people. But there are simultaneous conclusions. Thousands of people have come to the same conclusions as to what is wrong in many areas of mainstream science. The Big Bang is a good one. When you really sit down and think about it, and your PhD, your degree does not, and your job does not rely on your opinion of the Big Bang, and you think about it, why would all the mass be in one place? And if they even say in the Big Bang that space and time itself, they're like, and it's the size of a pea, and then it all expands. Why? Why did all that? Why did it collapse? Why would it collapse? When in reality we're seeing with our telescopes the light. We have the life and birth cycle of all with stars. We know how they explode and go away, and we know how they get come back and form again. We know how solar systems form. We see a constant life cycle. Well, why a Big Bang? So thousands of people come up with all arguments against a lot of things, relativity, because they think about it, and it's not a coincidence, folks. When you search for truth. And truth, hopefully, is something that is hard to dispute. It's never absolute, but thousands of people have come up with the same types of conclusions. And they first work in isolation, but they eventually find each other. Of course, that was a lot harder when the MPA started in the early 1990s. You didn't have the internet. And so people were communicating via telephone, looking up in books, people trying to find them, etc. So let's take a look at, we're going to take a look at each of these areas of dissident areas. So I put together, and forgive me, folks, I put experts down, and you can totally disagree, and you should disagree. This is from me last night, putting all this from my head. I've been involved. The person who probably knows more about dissident science than me is Greg Volk. I'm one of the people who know a lot because we made a database of over 10,000 items of books, abstracts, and people, almost 3,000 dissidents. So I know a lot about these people. I build a database with it. So these are just things off the top of my head. They are in no way the right answers, especially for experts in new models. So let's just examples off the top of David Hilster's little head. Okay. So relativity, GPS shows its flaws and does not support it. Ron Hatch, bless his soul. He was my first investor in my film. Was a super great guy. He had over 30 patents in GPS. He just recently died. I think he died last year. It's a shame because good thing is we gave him a lifetime achievement award. But that he said in my documentary Einstein Wrong, GPS shows flaws in relativity. In fact, he was working on a 0.56 picosecond difference in transmission speeds that NASA couldn't figure out. And he was communicating with NASA saying that he thinks it's because it's the speed of C plus the speed of the satellite. That violates Einstein, doesn't it? So, but many people in our organization don't believe that the speed of light is a constant. There's a general, when we measure it here, there's a general, how do you say, average of what it's going to be, but a lot of people don't believe it's constant. Mass increase is not observed in particle accelerators. Go to einsteinwrong.com, and you can watch my film. And in there, I have a experimental physicist who works at the Stanford Linear Accelerator, who on camera and in my film says, we do not observe mass increase. Okay, we're accelerating particles to really close to the speed of light. That's sort of violent. In fact, he says we have to unteach special relativity. This is when I called him a theoretical physicist, you just thought I insulted him and called his mother a name. So you can see there's a lot of people. Relativity, find a relativity expert in the world. There's only one really, Kip Thorne. The rest, nobody teaches it really very much. It's funny. So atomic clocks, unplane experiment, data manipulation. Again, EinsteinWrong.com. I talked to Dr. Eberly Spencer. She's got a degree from MIT, and she got the raw data from the atomic clock planes, and boy, did they fudge it. They basically had to start the experiment before it started. I mean, literally, the line on their graph, they had to move it like 23 hours before the start of the experiment in order for it to fit general relativity, or I'm sorry, special relativity. So experts in the field of relativity, Dr. Cynthia Whitney, she got her degree at MIT in special relativity. The first thing she did was to apply special relativity to gyroscopes that have light going around. They use light and gyroscopes for orientation. And guess what happened? It failed miserably. It failed so much that she went back to her professor at MIT and says, Professor, I just wrote my doctoral thesis on special relativity and it doesn't work. And you know what the professor said? Oh, we know. But, don't worry. That's true. And we have an Einstein web page, a Facebook page with almost 20 million people worshiping a guy who's wrong. So anyways, experts also, Nick Percival, if you haven't checked out The Nick of Time, look up The Nick of Time. He's got he's a great mind thinking about relativity. I love his videos. Go subscribe to him and look at him. And Steve Bryant, who we're going to be talking about in this, he's got he absolutely obliterates relativity, and that's we'll be talking to him. It's called what's it? Oh my gosh, where is it? Something of physics. Sorry. Disrupting. There you go. Disrupting physics. Sorry about that. So new model, Steve Bryant has a new model for relativity. Again, we're going to be talking with him. He has promised to come on here. And Dr. Riccardo Carasani has an autodynamic theory where he replaces the relativistic equations and they turn into Newtonian equations. Newtonian. There's no relativity. So if you haven't checked that out, go to autodynamics.org or look up Dr. Riccardo Carasani. Okay, we're going to talk about the Big Bang next. Well, the redshift have the Big Bang pull back. Why did somebody think there was a Big Bang? Because everywhere they looked in the universe, they saw what they called a redshift. So it's the same idea as when an ambulance or a police car or a fire engine goes by you, it goes, so it goes, no. You hear that shift in frequency. Well, that's what they thought. Oh, there's a shift in frequency, a red shift. That means it's moving away. So everything's moving away. Oh, there must have been a Big Bang. And so that's where the Big Bang came from. And of course, then you have to think about redshift. Redshift has other explanations. Tired light. Light cannot travel forever without some type of effect on it. So that's what dissidents talk about. Halton Arp's evidence against the Big Bang with peculiar galaxies. Seeing red. Look up Halton Arp, Seeing Red. Just amazing, where you have galaxies and you have quasars coming out of that are linked visually and spectrally to the um, galaxy, and yet the redshifts on those say they could not be even close to each other. And of course, when he started telling people this, all of a sudden his telescope time disappeared, got smaller and smaller until it disappeared. Luckily, before he died, our organization gave him a Lifetime Achievement Award, because if we were in a different universe, he would have won the Nobel Prize in cosmology, or if they have one, I don't know. And the Cosmology Quest documentary, you can see that all online. Randall Myers, I know who he is. I've talked with him many years ago. Really good guy. He's a composer. He makes a really good living making composing for films in the United States and in Europe. He's got a villa in Italy, but he made this Cosmology Quest documentary. If you're not into the actual content, you go to sleep. He says he shows it to his friends to go to sleep, but not us, because we like it. It's well worth seeing. I'm talking about entertainment for your friends. Whereas EinsteinWrong.com, I made sure that people who don't know anything about science are going to like it, even if they have no idea what's going on with that. So, anyways, experts in the area of Big Bang, and against it is Borchert, Dr. Glenn Borchert. George Coyne, in his book, talks a lot about the problem with the Big Bang. And of course, there's other problems. There it is. I've got so many. It's going to fall down because I got so much stuff here. Yeah, here's one. Let's see. Let's see what that says. Bye bye Big Bang, hello reality. So that's what you got, live TV. I always rip apart my collection back here. But again, the new model is the universe is infinite in space and time. And when a person asks me about the Big Bang or something, I'm talking to a layman who doesn't not like us. They go, Dave, the Big Bang's wrong. I said, okay. Did you ever learn about the life cycle of stars, like how they're born, how they're made, and how they die, and solar systems? Oh yeah. Well, if there's a Big Bang, which is a one-way trip, why do we see cyclical life-death cycles? And they go, oh. So there you go. Anyways, we've got lots to cover here. Here's the Big Bang. It's fireworks. That's pretty cool. Cosmology. Well, the evolution of our solar system. There's many different models now, including that we know that mass is increasing in all the planets and all the moons and all that. That's one proposal. There's evidence that we see for it on the surface. We have evidence here on Earth that mass has increased because of the dinosaurs couldn't live today in today's gravity. There's all kinds. Again, these are all theories. The sun models are wrong. There are really great people. Robitaille, if you haven't looked at him, he has a great scholar, Sky Scholar, I think it is, Sky Scholar. Look up that guy. He is just totally tearing apart models of the universe, including sun models. Really great guy. Quasar and galaxy models are not understood. Halton Arp again. Oh, no dark matter or energy. Newton explains. Go look up dark energy, dark matter, and it's funny. The galaxies that are spherical shaped don't have dark matter, they say, because all the stars are going around a spherical. They have a spherical gravitational field, whereas galaxies that are like this flat, they don't have a spherical galaxy gravitational field. And if you go and calculate things, the speed of the stars on edges of a galaxy can be explained by Newton. So no dark matter. Anytime you see dark, throw it out. What that means is, it means two things. One, that the mainstream doesn't know what it's looking for. Their stuff is busted, so they have to invent things. And then secondly, when they invent things, then they go find them, because that's how they get Nobel Prizes. And the Electric Universe is a really big group. It's been keeps on growing, where they talk about how the universe is way more way more than electric than gravitic, and they do really great work. Experts is, again, Robitaille. Rigbasal, he's from our organization. If you haven't seen him, look up on my Dissident Science, just do Dissident Science dark matter. You can see a video where I talk very extensively about that. And you can see his lectures on our website. Just look on Cameron Ribixall. And then, of course, Wal Thornhill and all the Electric Universe people, they talk about a very different cosmology. And new models are Newton. The whole universe can be described in Newtonian. And also plasma. A lot of, like, the Electric Universe talks a lot about plasma. Plate tectonics. Plate movements are a disaster. Go look and try to find even any consensus, let alone any videos on how the plate tectonics world work according to the standard model of plate tectonics. It is a joke. It's just, if you have any engineering at all in your brain, you're going to look at that and just sort of laugh. There's not enough subduction. The idea to keep your radius, we know, and even standard model says we have seafloor being built daily. And in fact, it's adding, about the Earth's radius adds about, or some of these expansion plates add about the size of you, a couple meters in your lifetime. So we know that's growing, but they don't want to think that the Earth itself is growing. So they say everything that's growing in the oceans have to be subducted along the edge. Well, they can only, if you dream, and you dream really hard, you can get maybe 30% of the world's new seafloor bed subducted. That means you got 70% you can't explain. Here's a good one. Go look at the ridges around Antarctica. You're going to find there's no subduction in Antarctica, and yet it's growing all the time. Maybe that's the reason why there's so little land on the south side. Take a globe. Look at the southern hemisphere. Way less landmass. But again, these are all problems. The flora and the fauna paradoxes abound. They have lizards or chameleons or these little guys that run around, reptiles, on an island in the Pacific that, if you look at expansion tectonics, at one point, the Australia, for instance, was was right along the coast of the Americas. And they find geological and flora and fauna that match that perfectly, but that's not exactly the way plate tectonics says. They don't know what to say. They have the same thing going on. So you have reptiles that can't swim in the water that are on the Pacific Islands, in the Pacific Islands near Asia, and only on the coast of this place in Chile, and they can't figure out why. So expansion tectonics is the answer for people. And of course, the experts in this, by far, the king of them all is Max Lowe. He's going to be giving us 2 more lectures, which is really great. Just incredible work. He's the greatest geologist of all time, in my opinion. Stephen Hurl, who talks about who's a mechanical engineer, says, guess what? I can calculate the gravitational fields by even measuring the femurs of dinosaurs. He gave a talk on that, actually, and many, many others. There are quite a bit. In fact, if you get Stephen Hurl's book, recommended for everybody. There it is, Earth Expansion, The Hidden History of Earth Expansion. This is a gem, and it will tell you everybody who's working on it before and today. Absolutely a wonderful book. And you can also check out my interview with him on this Saturday morning chat on both Dissident Science YouTube channel and as well as the CNPS YouTube channel. All right, let's keep going. Quantum mechanics. Oh my gosh. History eraser. This is quantum mechanics today. There are people in the last decade who have sat down on stages and said the following. If I and you are looking at a photon coming from a galaxy, a star 10 billion light years away, if I look through it with a telescope and you look through it with binoculars, the way quantum mechanics work is that you're going to see it go around one star because it's coming toward me. It's got to go around a star. You're going to see it go around the star on the right side, and I'm going to see it on the left side. And how do we reconcile that? Well, the only way we can reconcile that is that we have human brains, and all those human brains have this consciousness, and the sum of all the consciousness will finally decide of all the infinite amount of possibilities on the real true possibility. This is the state of quantum mechanics. All the stuff we hear about, it sounds so important, right? Well, mechanics doesn't. It sounds Newtonian. But quantum mechanics, quantum's the quantum. And you hear about this over and over and over. And what it really is the subatomic world, what goes on. And it's just philosophical disasters, such as action at a distance, at a spooky difference, history eraser. Go look that up, history eraser. Think about it. And the double slit nightmare that they have created from themselves, where particles can be in two places at once. I mean, seriously, this is no better than voodoo science, or the shaman who makes up, all these, spirits and all those things. No offense to anybody, but it's, a lot of fairy tales there. Experts in this area in quantum mechanics is, no, that's wrong. I'm sorry, completely, boy. Experts in this area. Eric Reeder is a person in this area, so I apologize. That's wrong. That was for you can see I copied the last slide. The new model's okay, but I forgot to fill that in. But Eric Reeder is a person that talks a lot about quantum mechanics. That's one right off the top of my mind that he's in our organization. So sorry about that. Philosophy. Thomas Kuhn. Today we are in model revolution. That's my opinion. Most people think we are in model stability or model drift. If you ask the standard people in the standard model, standard in mainstream science, are going to say we're in model drift. We are in model revolution, obviously. And I'm actually going to show a video that I made a while back. It's a 10-minute video. We're going to see later in this talk coming up about that. Consciousness and free will. With new explanations we have in the philosophical world. That's something, and experts in that are Borchert philosophy, without a doubt, Borchert and his 10 assumptions of science in his infinite universe, and then Coyne also with his consciousness and free will. We had him on talking about that. So check out our previous videos. They're absolutely incredible. But philosophy is really, really important. And infinite universe, 10 assumptions of science. And these what I can see as the top people today. Amazing, amazing work. Structures. The standard model is so ironic, isn't it? What's structural in the standard model? Almost nothing. Go look up quarks. My favorite is go look up quarks. Look them up in Wikipedia and look at the structure. It's a circle with 3 other circles, and all perfectly placed. They have no physical representation at all. It's just a Venn diagram, and they have squiggly things between them. It's ridiculous. It's just absolutely ridiculous. But there's very little physicality to the standard model, a lot of math. Experts in the area of structures, Don Bradell and his structures group, Greg Volk, who is a person who's taken a hiatus because he worked like crazy for this group. He's really into structures. Structures people were at our conferences with tables of structures and talking about them. Extremely, extremely important. You put spheres together. How do the atomic structures go together? If you look at the gold spheres, like I said before, on YouTube, and you can see the actual atoms. They're forming their spheres that are next to each other, forming sheets of hexagonal sheets of these spheres. All of these things, the structure of things are everywhere. They say structures are everywhere. And I'm helping Don Bradell and the Field Structures Institute get up off the ground with their new website. And they have a structures group on our naturalphilosophy.org. And so you're going to see much more about the structures group. They're really into Buckminster Fuller as well. Field Structures is with the Bradell group. And mathematics. Mathematics is wrong? Yes. I mean, our mathematics, we've proven all these things, and we see the square root of -1 is I, and we use it in equations, e to the something I can't remember all the things. I'm a mathematician. I've got a bachelor's degree in advanced calculus. I love mathematics, but we have a big problem with the square root of -1. And we think of it as, oh, that's just the weird universe. And we have things, we know that the square root of -1 shows up in nature. Think about it, folks. You think the universe knows about the square root of -1 and I? Are you out of your minds? But many of us think that. And of course, negative numbers. Okay, think about it. What is negative in the universe? And I'm not talking about charge, because we have models. We don't need negative charge. What's negative in the universe? Think of it. You can talk to my dad about that a lot. And the experts in this is Peter Erickson, a great friend of mine. I won't say his name. Thought this guy was nuts. Peter Erickson. He was giving a talk, and he blew my mind in about 4 minutes. He said the square root of -1 is -1. And he was talking about it. I'm a mathematician. It was blowing my mind left and right. And this guy said, no, this guy really has, it's really amazing work. If you haven't, look up Peter Erickson, the square root of -1, also variable numbers. And Hilster and Hilster, my dad and I are very much into this idea that there are no negative numbers. And of course, new models, the variable new models, there's the veritable number system. And again, read Peter Erickson's book. I have it back here, but if I go digging, I probably won't find it in time. And no negatives. So how can you do that? It's just, we're picking origins, and we made this stupid thing. Think about it. Even you have this line, and we pick somewhere, and on this side, you can write a symbol for it. On this side, you got to put a negative in front of the symbol. I don't know. All right, particle physics. The standard model has little physicality. That's true. There's a particle zoo. They're basically arbitrary packages with arbitrary attributes. That's a quote from Dr. Alexander Unziger, German physicist. So go figure. And of course, experts in this area is Alexander Unziger. I've already talked about this. And read his book, The Higgs Fake. You will see that the engineering and scientific practices going on in particle accelerators is an abomination. If you were to send the SpaceX team or a NASA team of engineers to the linear particle accelerator, the Large Hadron Collider. Okay, I was thinking Stanford Linear, sorry. The Large Hadron Collider. Send them, and then have the software engineers and everybody else explain the way they filter things out and the way that they handle data. Within hours, they would just tell these people they're out of their minds. And if you read The Higgs Fake, you're going to see the way, the ridiculous way they go on. They basically say, we're going to find this strange signal in the middle of all this mess. And they just, if you bash something around literally billions of times, you're going to find the pattern you want. And once you find them, then you learn how to filter them out. There's no proof that what they found there's no proof that what they found isn't still noise. And when they do find it, they claim that they found it, then they filter everything else out, and then that becomes it. So they arbitrarily smash things together, supposedly pick things that are going to describe what that particle is, and then they filter everything else out, and then go to the next one and do the same thing. We have a lot of models, people working on a lot of models of subatomic structure. Featured scientists. Well, we do have lots of featured scientists, and those are actually on our website. And this is where people are going to say, who are you talking about? Well, we do have a website. So I'm going to take that down right now. We're going to go to a website right now. I'll bring that up in the screen. We're going to take a look at that. Bring this over here. And Science Woke. We're going to go to our scientists, and I am going to share this with everybody. So if you want to know, we decided with this, our organization, that we were going to come up with a magazine called Science Woke. It's online science magazine for critical thinkers. Now, the idea of this is you can come here and you can figure out problems in science. You can click on this and you can find all the problems in science, and you can click on each one of these, like relativity, and we talk about what's wrong with them, and we have lots of articles about them. We only have 2015 abstracts about the problems with relativity, not many scientific papers written about that. We only have 320 books that are related to the problems with Einstein's relativity. You can see there's really nothing, Einstein's I'm being sarcastic, obviously. Plate tectonics, all of these. This is made for the average person, looks great on their phone since 60% of the world looks at things on their phone today. So you can see that. We have lots of articles that people can look at it, and we have new theories, and we have scientists. And these scientists are the movers and shakers of today. This is Dr. Cynthia Whitney, and we have a little thing, a female with PhD from MIT in physics and relativity who is now a critic of relativity. She is our chief sponsor. Well, she is actually does give money to our organization, but she is our chief scientist. We have Dr. James Maxwell, all continents fit together on a smaller globe, like a jigsaw puzzle, expansion tectonics. Dr. Pierre Robitaille, stars are not gaseous, but are made of solid lattices of hydrogen metal. He's got a lot of evidence for that. Dr. Helton Arp, unfortunately, he has passed away. That redshift is not related to the velocity, but intrinsic to stars, galaxies, and quasars. Here's an interesting person. Now, here's a guy who's a real astronomer with telescopes. Here's a guy who is a retired lawyer and a retired Supreme Court justice. And he has a theory, his own theory of ether for physics. I call it the Vancouver theory. And he's got some interesting ideas that ether moves in and moves out. But there it goes to show you. We listen to what people say. We don't care what your title is and whether you've gotten a PhD. If what you're talking about is very interesting and logical, we don't care. Of course, Walt Thornhill, he is very well known in the electric universe and one of the leaders and proponents of the electric universe movement. They have the Sapphire Project, fantastic project. It's to me the best experiment by dissidents today and running today. They're making they're using plasma and trying to simulate the sun, and they're creating really heavy molecules out of nothing, it seems. Wow, is that interesting? Here's another person, Dr. Edward Dowdy, laser optics physicist and electronics engineer, retired. NASA scientist uses observational analysis to show gravity does not bend light. Nothing big to see here. Eric Reeder, I talked with him about him. He's man, that guy's mind works in different ways, but in good ways. And he performs experiments revealing flaws in quantum mechanics and resolution of the wave-particle duality. He gave a talk about that. It was quite good. We just got so many huge people here. Just giant after giant. Here's another giant in our field, Dr. Gerald Pollack. We gave him in our last face-to-face meeting in 2019. We had our conference at the University of Washington. He found a fourth phase of water. Water comes in a fourth phase of these sheets. That's why when you see the meniscus on a glass, you can balance a coin on it. They found that that's called easy water. It's not ice, it's not gas, it's not liquid. It's a fourth state of water, and it's super important. Basically, life doesn't exist without it. Does anybody know about that? Nope. Stephen Bryant, he's a senior vice president at Wells Fargo. But the guy has a brilliant mind. He wrote a brilliant book, Disrupting Einstein and Rewriting the Rules of Physics. Great book. One of the greatest scientists in my time, of all time, and was living with us. And even though he's in a profession that he doesn't agree with, a huge other thing that we all agree with, maybe he can't say it, goes to show you he has a paradox within his own profession. He's in a certain profession, but he is, in my opinion, considered to be one of the best, if not one of the best, or the best all-time scientific philosopher all time. He replaces the Big Bang with an infinite universe. He has the infinite universe theory, but infinity and the 10 assumptions of science, our model doesn't exist without those. And a lot of people are standing on his shoulders. Dr. Alexander Unziker, he's a physics teacher and science writer, German physicist and science writer, taking on all of particle physics. He interviews the guy, David somebody, who won the Nobel Prize for supposedly simplifying the 19 different attributes that they give all the particles in the particle world. And he starts asking this guy questions because he thinks he's just being interviewed, and he's talking. I mean, you just watch this guy's like talking and like he's the Pope and he's giving decrees to the world. And then Unziker starts throwing stuff at him. He starts leaning in again, and finally he's got his hand on his mic until finally he gets rid of the mic and almost storms off. You got to look it up. Look up Dr. Alexander Unziker, and he interviewed a Nobel Prize laureate. Standing ovation for Dr. Alexander Unziker. He's one of my heroes, one of the few science writers out there telling the truth. Dr. Vladimir Ginsburg. He is a retired engineer and computer programmer, inspired on a night by a beautiful night sky in Phoenix, Arizona, to come up with a whole model of the subatomic world and atomic structure and all that. Nick Percival, I think he's a Harvard grad, physicist and entrepreneur, talks about Einstein's special relativity, takes on Einstein's special relativity head on. He has his own YouTube channel. He put together a bunch of lectures which are being viewed all the time. You want to take a look at that. You want to know the real ins and outs of special relativity. He's about it. Here's a VP in Innovations and Partnerships. He's not a physicist, but he greatly simplifies the standard model and its number of free variables using the energy wave theory. Look up energy wave theory, Jeff Yee. Fantastic model. I love his model. Just amazing. Another amazing mind that and she's now starting her own theory, works with Untitled Chapter over here, and is an etherist and a computer scientist and doing lots of, check her out, Fractal Woman. She passed me. Dissident Science, because, her stuff isn't so controversial. I'm just not nice to science because I want truth. I don't care about being nice. I don't talk people down. People think I'm mean because I tell them the truth about the standard model. Well, then so be it. But she loves fractals. In fact, part of her work, one of her fractals in our book, because of the infinite universe, very important. But she has her own ether model now, and she's got videos and modeling how ether can travel through waves and makes magnetic fields. So that's pretty amazing. Harry Ricker, I think he may, I've seen him jumping in and out here. I don't know if he's around. Let me see if he is. Well, anyways, he jumps in and out. He is one of the great writers. If go to Science Woke. I still need to put some of his articles. Sorry, Harry, I haven't put them all up there. Fantastic writer. I mean, he's just prolific and I love his writing. He is, in my opinion, the best dissident science writer out there. And he's cantankerous, and I love that because he's an electrical engineer. He's like my dad, electrical engineer, and they're all cantankerous. So, Yonel Denou. I saw his videos of the underwater experiments he did in 2008, and I fell over. We had him talk to our group. Unfortunately, I think we lost those talks because it was on DimDim. Yeah, there was a video service like this today called DimDim, and we saved a lot of them, but I have a lot of them. I can't get at them anymore. The format, I can't display them. But he is a physics teacher, and in his underwater experiments reveal the physicality of magnetic fields. Many of us are using that. I mean, we're all standing on his shoulders for that. It's fantastic. Dr. Raymond Gallucci. Now, here's a guy who doesn't have his own theory, but if you want him to give calculations on whether your idea is plausible, like you want him to give you an engineering spec to see if your theory and your physical model is a possibility. He loves doing that. You give him something, he'll stick on it. He just gave a bunch of talks recently on the electric universe where he showed that a lot of their ideas are possible. I love that guy's work. Stoyan Sarge is electrical engineer and physicist, and he has his own model of atomic structure and a lot of the universe too. My father is a retired electrical engineer. He has one solution for the wave-particle duality. When I saw that from him, that's my father, electrical engineer. I fell off my chair. I mean, I went ballistic because I told him, I said, you solved the wave-particle duality. It's a solution. And he's, I didn't. And then 2 weeks later, he came back and says, I think I got this is one solution for that. And I go, yep, you did. George Corney, if you haven't seen him, he's got a beard now. He's talked on our group. Go back a couple of episodes here. You'll see him talk about, he's called it Notfinity Process, Microcosms in Motion. I have his book. We're going to be publishing that soon. I've been busier than busy. I got my own job. I work as a 40-hour, well, more than 40 hours a week in the supercomputing department at LexisNexis here. I've just been busy getting computers to understand human language. That's what I do. but I love this stuff. I can't keep away from it, and I wish I could clone myself, but I'm busy. I'm sorry, George, about getting your book out. I need to do that. Stephen Crothers, another amazing story from down under, from Australia, independent research and theoretical astrophysics. He tried to get a degree at a university, and they kicked him out because he wanted to say black holes and all their equations are all garbage. And he shows that. There's so many problems with the black hole mathematics. It's ridiculous. He takes on black hole mathematics head on and has paid the price. You can read about his story on our website. We have a part of this website called Eureka Moments or whatever. Where am I? Don't go. Oh, there I am. I'm working on the. I built the website, so I pretend I'm important there. So, anyways, no, I'm working with my dad on particle physics, and I talk a lot about the world. So I'm more of the person who is out there championing everybody, knows a lot about stuff. What I'm doing here today, this is talk's a perfect example of it. So if you want to get a loudmouth out there yelling to the top of my lungs about how the standard model is wrong and all these people you're looking at here are great, no, that's me. That's why I'm there, I guess. Stephen Hurl. He is a mechanical engineer. Dinosaurs were so huge because the Earth had half the size and gravity was much less. Again, we have lots about him. Neil Adams, the reason I even knew about expansion tectonics, I saw his videos from 2005. I even got him to give a paper in Maryland at our conference in Maryland. He has the prime matter particle theory. Believes the whole universe is growing from every asteroid to Jupiter. In fact, James Maxwell or other people in that group also think that the Earth will eventually become a gaseous giant as it's growing. Ken Moore is a computer scientist working on the velocity escape and network performances metrics. It's a different person, James Carter. He was actually featured in one, probably the most famous DISSIDENT book ever written in our modern times, which is the Physics on the Fringe by Margaret Wortham, who does probably pop into our hi Margaret if you're watching this, how are you? But he was in that book, and he's an amazing guy. He's got if you haven't checked out his work or his book, check it out. Great critical thinker. And we have Musa. I think I'm supposed to fill some of these out, but Musa is a great mind. He comes to our conferences to give great papers. He's from Nigeria, and he's actually teaching kids who like science around him to be critical thinkers. Heaven forbid. So that gives you an idea of some of the critical thinkers out there. So I'm going to come back to my slides here. So those are the featured scientists, and you can see those all on Science Woke. Why are we in model revolution? Normal science. Here's the cycles of science. Normal science, science drift. This is science drift. I should have put that here. I'm sorry. Science drift is where everybody thinks we are in mainstream science. We're in normal science, it's doing fine, but we're starting to drift away. Pfft, you kidding? We're not even in model crisis. We're in model revolution. The reason is there's so much data. We know that the model is broken. You got to throw most of it out. We are now in model evolution, and after that, you get a new paradigm. Well, so I am going to play this, and hopefully I'm going to have check to make sure the sound is coming out. So everybody in the comment area, I know you've been making a ton of comments. I'm sorry about that, but I do want to get to this through this talk. But I'm going to have us watch this a video that I made about why we are in model revolution, why there are so many models out there. So hopefully you'll be able to hear this because I should be coming with computer audio. No audio? Okay, no audio. All right. I see people. All righty, so I'm going to unshare that. Let's see, stop sharing. I should be able to share. Oh, you know what? I may not be able to do it because it's embedded in a PowerPoint, and I assumed that would happen. So I'm going to give it one more shot. It supposedly says share audio with it, so I'm going to give it a shot and see what happens. All right, one more shot. I'm going to watch my dad, who's in the green room, and if he's shaking his head, he's going to. I'll know. I don't think it's going to work. ago, I set out to
How about
find an
now?
explanation as to why there are so many
Okay, I hear
different
something.
models of the universe among the group of scientists I see as the best critical thinkers in the world. It seems almost universally accepted by the science world community that we are lacking a physical model in mainstream physics. The result are dozens of scientists with dozens of different models. But why so many models and why now? Are we lost? Or are we doing the correct thing at the correct time? I didn't find anyone with the answer to these questions, so I had to come up with one myself. Here is what I found. My journey started with the most famous book written to date on scientific paradigm shifts. In 1962, Thomas Kuhn wrote the seminal book on how science advances, entitled The Structure of Scientific Revolutions. In fact, the phrase paradigm shift was coined by Kuhn in this very book, and the phrase is now commonly used in philosophy for any grand change in direction in any field. Although I agree with the Kuhn cycle for paradigm shift, I disagree with how Kuhn and others applied this cycle to science history and more specifically physics. Kuhn and others identify various paradigm shifts, including the shift from the geocentric solar model to the heliocentric, the birth of Newtonian physics, and Einstein's relativity as some of the most important scientific paradigm shifts in the last 1,000 years. But after working for more than 2 decades with some of the most brilliant critical thinkers outside mainstream, and studying the history of physics starting with Isaac Newton, I have come up with a different interpretation of what people call the Kuhn cycle, and thus found a satisfactory and surprising answer to my questions of why so many models and why now. The Kuhn cycle consists of pre-science, the time before modern science, normal science, model drift, model crisis, model revolution, paradigm change, and then back to normal science. Let's just consider physics. Assuming that pre-physics or pre-science was before Newton, we can say that normal science in physics started with Newton's Principia. Newton's work on force and gravity was a revolution in science, and his work is still used today, and without it, modern life would not exist. Interestingly enough, we see in Newton's own lifetime that physics started to shift to the next stage in the Kuhn cycle, model drift. Model drift says, when issues, problems, or phenomenon appear that the model cannot handle, the model begins to drift away from normal science. As soon as more than a small amount of drift occurs, the field's paradigm is said to be in model drift. Newton and his contemporaries started to think about the physical cause for gravity and light, and thus ether and gravitons were postulated. Although Newton never publicly supported an ether or graviton model, these notions are still championed today in some of the modern theories being proposed. In the following centuries, scientists tried to find evidence for ether and gravitons, and in the late 1800s, the Michelson-Morley experiments, which tried to detect ether but could not, are seen by many as the climax of the third stage of the Kuhnian cycle, model crisis. In this step, a field's model of understanding has drifted so far that the field is thrown into crisis because they can no longer make rational decisions. Their foundation for solving their central problems has been shattered by discovery of too many anomalies their central theory cannot explain. Michelson and Morley seem to have proven that ether does not exist. This flew in the face of the double-slit experiment, which seemed to show that light was a wave. If it was a wave, it had to have a medium. But since there was no medium, physics seemed to enter into model crisis. Einstein to the rescue. Einstein proposes the photon for light and space-time for gravity, and according to Kuhn himself, Einstein's relativity was a paradigm shift throwing physics back to what Kuhn calls normal science. Yet, if you talk with today's critical thinkers, they see this in a very different light. Ever since Einstein's special and general relativity were proposed, there have been critics. Those who have criticized Einstein throughout the last 100 years have been disputing Einstein's model as a paradigm shift. My best explanation for why physics has accepted Einstein's theory as a paradigm shift has little to do with science and more to do with power and fantasy. It is much easier and lucrative to sell a magical, mysterious universe that only a few people claim to understand than a model of the universe that is simple and everyone can grasp. Arrogance is what has kept physics in model crisis, and Einstein and his followers have only made the crisis worse. Einstein's arrogance that the universe must follow his laws was followed by the invention of many imaginary particles, including the neutrino, the quarks, the W and Z particles, and now the Higgs boson. Science arrogance has produced an elite class of scientists who are not elite for their incredible minds and amazing models, but for their exclusion and fanciful inventions that today are starting to look downright silly. Einstein's relativity, according to the best minds in physics today, is wrong and based on bad assumptions. From NASA scientist Dr. Edward Dowdy showing light is not directly affected by gravity, to Dr. Cynthia Whitney, whose PhD in relativity from MIT, who found fatal flaws in special relativity, to Ron Hatch, a GPS scientist with over 30 patents showing that GPS shows flaws in relativity. Relativity, as they say, is dead. With all this in mind, here is my proposal for a new interpretation of the Kuhn cycle as it pertains to physics. Newton takes physics from pre-science to normal science. Model drift starts during Newton's lifetime. Model crisis starts in earnest with Einstein's theory of relativity and goes through most of the 20th century. It is the next step that tells us where we are today and why. The old model failed, which caused model crisis. Model revolution begins when one or more competing new models emerge from the crisis. And there is the answer. We are in model revolution. We have ether, particle, lattice, and structure models that today are competing with one another to become the next paradigm shift in science. That is why the John Chappell Natural Philosophy Society exists, and that is why we have so many competing models. Mainstream science, as well as many dissidents, believe that there should be only one theory at a time because the universe works in only one way. Many are familiar with Kuhn's book on scientific paradigm shift, but most know very little, if anything, about the Kuhn cycle and even less about model revolution. But according to Kuhn himself, model revolution by definition will be able to sustain multiple models because there is so much new data to take into account. The old models simply cannot be stretched to explain the new data, so a new model must be proposed. And with such ample data, there is room for different models to describe the same data. And therein lies the clue to where we are today in the Kuhn cycle. This little-known part of the Kuhn cycle called model revolution turns out to be extremely important for every critical thinker today. Everyone, and I mean everyone, needs to know this because mainstream science and model builders themselves claim there can be only one model at a time and don't understand that in the structure of scientific revolution, Kuhn himself recognizes the importance of model revolution and multiple models. And when one of those models wins, and everyone accepts it as the current best model of the universe, a paradigm shift will take place, and the Kuhnian cycle will have come full circle from Newton. And we will be back to normal science until that model too starts to break down and begins the cycle all over again. The big question you probably have for me is, Dave, what model will win and when? Will it be an ether model? Will it be the electric universe model? The answer lies in our ability to finally allow students in universities and anyone with the will to do so to be allowed to question science and take science forward. Universities today do not teach critical thinking in physics and cosmology. They teach their truths, and therein lies the problem. But that's another story. And if you are interested in becoming science woke and joining the model revolution, go to the website sciencewoke.org and read about the latest in the model revolution and how you can participate. And maybe, just maybe, you and your work will become the next paradigm shift we have all been waiting for. All right, folks. I hope you enjoyed that. That was certainly, I think, a really good explanation of where we were, and I figured I didn't want to go and repeat that. So those are the kinds of things I do on my YouTube channel. Let's move on here to our next slide. Here we go. So the new theories out there, the archetypes for the new theories are basically can be put into these categories: ether theories, particle theories, lattice theories, and structures. People that basically different structures, like, you know, the electron is a helix or something like that, or a ring. That's actually one of the people. Some of the people have that kind of theory. New theories earlier, there are many theories and models in the universe during the last decades in the CNPS and MPA. Now, these are just some of them. Believe me, there are a lot of them. But the ones who really produce, books, and you can read them and have been around a while, Vladimir Ginsburg, you've seen these people, Storian Sarge, James Carter. These are people that had done things earlier. The modern dissident groups, you can see here a little bit about the history. The MPA started in 1992, went to 2015. It continued in the CNPS. We just had a sort of a breakup and move on from the directorate. That's why we now have the members who are in charge. But there's also common sense science. Again, sorry, put these together late last night. So common sense science is, a lot of people are from that group, very prolific group too, early in the 1990s, in the early 2000s. Electric Universe, of course, we talked about, and the CNPS has a main group supporting all subjects, and now we have two groups that are putting their own group together, sort of subgroups in their own websites, who do work with us, and I'm helping with them. We do support it. That's what our group does. We do support it. Here are 5, I promise you, physical models of the universe. I'm going to look at 5 of them. The universe, I'm not going to look at them in detail, but in general: infinite universe theory, Dr. Glenn Borchert; energy wave theory by Jeff Yee; the OM particle by Laurie Gardy; and ether theory. I don't know if I think he has a name yet, by Ionel Danu. He's a Romanian teacher and scientist. And the particle model by Hilster and Hilster. My father and I have a model. And here is a very interesting chart for those who don't think we have, how do you say, concordance. We don't have agreement within models. The first 4 are almost all in agreement. The first 3 are, and that is, all of these models today are 100% Newtonian. Again, Newton's laws reign at all levels of the universe. And in fact, in our model, in the infinite universe theory by Borchert, Newton reigns at all infinite levels of the universe. And I'm not talking about outwards. I'm talking about structures bigger and bigger and structures smaller and smaller. You never find the end. All of them are describing light with physicality. Okay? All of them none of them have charge. And 4 of them are ether theories, and one of them is a particle model. Magnetism. They're all using pretty much the ether theory. That is the one you see here. This is Ionel Danu. He's the one that showed magnetism are particles flowing in circles or orbits. And we all subscribe to that. I'm actually, the infinite universe theory, I've talked to Glenn Borchert. He does believe that as well. I should put an X there, but I'm putting X's where people are actually trying to answer them. They don't have answer. If they don't have an answer, you don't get an X. Okay. Infinite universe theory, he does talk about Borkert about gravity, the way he thinks it works. Energy wave theory does. The OM particle, she does not include gravity yet. She just started on that. Ether theory from Yonel Danu doesn't. And the particle model does. Electricity, Borkert talks about it, but again, he doesn't give a mechanism for it, so I don't give him the X, but he says it's ether waves in a wire. Energy wave theory does have an explanation. He says for electricity, you go look on his site; it's there. He explains it, what he thinks it is. OM particle, she's working on that right now. Ether in a wire. So you can look at her website, Fractal Woman, and the Ether Theory by Yonel Danu. I thought they were working on that together, but it turns out Lori Gardee does work with Yonel, but she's working on that, I think, on her own. Then the particle model, we do have a model for electricity. And the quantum level, infinite universe theory says it's all Newtonian, but he really hasn't, Glenn Borkert really hasn't gone into the details. I don't think he ever will. Energy wave theory really goes into that quite a lot, very detailed. OM particle, again, she's not working on either as Yonel Danu. My father and I do have a model for that, how that works. Now, here are some things that all of these things are telling us today. These things are moot, meaning you can discuss them all you want, but they don't exist, so why discuss them? Charge, moving charges. Electric fields and moving charges. The moving charge create the electric field? Is it affected by electric field? Do moving charges produce electric fields? So if you have 5 people today working on pretty good models that aren't using any of these, then why are we bending our minds? For those of you who don't know, I've asked this question many times, and a lot of you may know because you follow me. Who came up with positive and negative in the first place? Answer, Benjamin Franklin. So just because I put a plus and a minus somewhere doesn't mean that it's an actual thing. But there's some people who can't get over this. But according to the new models out there, you saw them, charge doesn't exist. Quantum mechanics, there's no magic, there's no spookiness, there's no parallel universes that sort of there's no 4 dimensions, they're 3-dimensional. I should have put that down. I didn't put that down. There's only 3 dimensions that these see, I just made this. I'm going to have to build this chart better. And the universe is Newtonian all the way up and all the way down. The double slit with detector have Newtonian explanations. No need to unify relativity and quantum mechanics like the world's craving to do, because models should describe gravity and models should describe what's going on at the subatomic level. Particle physics, nothing is quantum. Newtonian mechanics can describe it all. New theories embrace some of the concepts of the standard model. Some of them do, some of them don't. Some will include the certain particles, and then some of them won't. And I think that's it for now. So get me back here. So I thought it would be interesting to talk to somebody. I could arrange this easily. And I'm not doing this because it's my father and because he's working on my, working in the model together. But I'm going to bring in my father who, let me tell you a little bit about him. He got his degree in physics engineering from the University of Michigan. Boo, Michigan, go Buckeyes. But anyways, and I was born there. He forced me, born Friday the 13th in Michigan. What can you say? But anyways, he had a very illustrious electrical engineering career. He was always in research, a really brilliant mind, and they always gave it, when they had a problem with a circuit, they always gave it to Robert D. Hilster. And so he literally made a living at using all the equations that all the electrical engineers use. Talked about current, talked about voltage, plus and minus, all those things, and always used equations, and there were negative numbers, I'm sure, in there. But now he's a person who believes in Newtonian universe, no negative numbers, and that a simple Newtonian explanation for electrical engineering. And get this, he's an electrical engineer and he doesn't believe in charge. So I'm going to bring him up. Hello, Dad. How are you?
Hey, I'm fine. Can you hear me?
No, I can't hear you. Can you speak again? Say
Hello?
us hello. You said hello. I still can't hear you. I'm kidding. It's funny that we always ask, it's really weird. We ask the question, can you hear me? And if they could, they'd answer. But I guess, oh, you're looking for a non-answer. But tell me, I think the interesting part, I just want to bring you up really briefly. I mean, obviously you grew up in the standard model of electronics, and you are a person that used electrical circuits all the time. And then when we started using a mechanical model for it, one of the things that you had said, why don't you tell me about the story about the first time you heard about charge and how you as an electrical engineer just thought, well, somebody said it. Can you give us a little brief story of how that came about?
Well, I think it was pretty much early. That light's too bright. It was pretty much too early when I was attending conferences, and frankly, it was either you or someone else at the conference that said they didn't think charge was real, that there was no physical explanation for it. And of course, as an electrical engineer, having used it one way or another for 40 years, I didn't accept the idea. I heard it and I went and looked around, and just go out there and try to find a physical explanation of what charge is. Sometimes you hear spin and charge being played against each other, but never an answer. Yeah, there's no answer about what the physical thing is, and it's probably a difficult thing to do. In electrical engineering, the volt, a 1 volt standard, a 1.1 volt standard, was developed by man. It doesn't exist in nature. So we had to develop a standard. You can go and get one and hold it in your hand. They even have an electronic version of that. The 1 ohm resistor has a standard. There is no 1 ohm resistor in nature. And so as engineers, we had to develop that and develop a standard. So, and you can hold these things in your hand. It's different for an electron, because an electron is just a particle. How do you build a standard for a particle? But it's a particle. So why does it have charge? Well, we all know the answer. The cathode ray tube experiment. Benjamin Franklin messes up the direction, and it turns out that whatever this particle is, it goes around and it hits the screen, and they say, wow, there must be a particle there. And we'll call it the electron. And it came out the negative end of the supply, so it must be negative. The value is really kind of arbitrary. And having looked for it, okay, I said, I get it. Charge is not real. But you find that standard, modern science uses these kinds of explanations. For example, they had taken an electron, and it's small, and they draw a circle and they put a minus sign in it. Then they take a proton over here. It's a big thing. And they say, well, that's got to be plus, because you see them being attracted, plus and minus. And with a hydrogen atom, a proton and electron, they're going around. And we all kind of understand that might be the electrical force Dave talked about that is pulling these together, but the speed is holding them apart. And that all makes sense. But now I'm saying, well, wait a minute, there's no negative, there's no positive. You take the negative and positive away, what do you get? Well, by the way, Coulomb's law says that the force between a proton and electron is from the proton, the big one, to the small one, plus to minus. You take the charge away. Electron has no negative, proton has no positive. What do you got? Mass. Now, if you ever listen to one of my videos, you'll hear me say it's not in kilograms, but it is mass. And when you take Coulomb's law and you remove charge, you get a gravity equation, just like Newton, working at a lower level.
Yeah, and that gives us an idea that, there are different ways to look at this. And if you look at the Coulomb's equation, it looks just like the gravity equation. So whatever your mechanism for gravity is could easily explain that. And that's one of the things the particle model does. And if you want to check out more about the particle model, my dad has, he's at particle.guru. We got that, and you can check him out, and he explains electronic circuits, the whole universe in a Newtonian way. We're writing a book. Hopefully that'll come out. He's also going to be doing a course in a Newtonian universe in our university. But you are here to say that you are. Go ahead. You want to say something?
Yeah, I just want to finish up on that charge thing. The standard force equation is from the proton positive to the electron negative. You take the charge away and you're left with just the mass. Guess what? The net force is the other way. They got the direction wrong, is all I'm saying.
Yeah. Benjamin Franklin and Coulomb got the directions wrong. Well, it's arbitrary, as you said. I mean, this whole thing is an arbitrary system. Don't get me wrong. I mean, the systems work quite well, but one other thing is I do want to use you as an example. One of the things that people say is, if you have a new model, this is the first thing. Well, what can you predict that we don't know? And as an electrical engineer, once you converted electrical circuits into a Newtonian physical world of moving particles, was there anything that, give us one idea of how a new theory or new model today is able to predict something that you would never have seen, and that maybe you could even measure it. Can you give us a short version of that?
You must have read something I said one time, or heard something. Okay,
yeah, give us a short
the short version is, in an electrical circuit where it's the battery of a DC circuit with a resistor or two resistors in series, the particle model suggests that the electron comes out chargeless, so we call it a G1. That's just a name, and it comes out of the battery because it was an orbital. It moves at speed c, and it goes around the circuit really fast. That's what it says. Now, you can't measure that easily, although there is evidence for it. But one of the things that in a particle model, and if you knew anything about Lessage's gravity, as a particle goes through something, it interacts, hits, and scatters. Interacts, hits, and scatters. And so I'm looking at this circuit, and I'm thinking, okay, this chargeless electron is coming around at speed c. It goes through a resistor, hits something, it scatters, it loses. The number out is less than the number in. I said, wow, that's just like voltage. It's like a voltage drop. So instead of charge, I assign to our version of the chargeless electron, the G1, I assign a voltage, not charge. So that as the particle goes through, hits resistance, the more the resistance, the more scatter, the more loss. So there's an equivalent voltage drop for the loss. Guess what? The battery actually adds. Now, I did an experiment. You could go online, look at the 2R, 3R resistor experiments. I did it, and I showed to a 70 or an 80% probability, correlation, 70, 80% correlation, that current actually reduces from the negative around to the positive. It gets smaller and smaller.
How did you measure that?
With a 6.5-digit multimeter.
Yeah, okay. Let me explain for those people who don't know about electronics. This is 6.5 digits, 0.0000001 accuracy. So in order to see the prediction of this particle model for electronics, you had to buy a multi-$1,000 voltmeter, which actually I found out. I looked it up, and these voltmeters are used in astronomy. They're used in astronomy because when they are doing things for astronomical, things are really small and they get really small signals. They've got to measure these things and test things. So that's where it comes from. So you used a 6-digit to 0.000001 to measure a change that no one would ever really see because you have a model that predicted that. Is that right?
Exactly. And since I actually rented the 6.5, I have since bought for 2,000 a 7.5, but I've been so busy with videos and the book and everything, I haven't had a chance to repeat the experiment or do some others. I have some others planned that the model predicts in terms of parallel resistors. Our model shows you why the current splits the way it splits.
Okay,
Quite
Dad.
interesting.
Yeah, it is. Thank you so much. Again, I didn't bring him on because it's our
Yeah.
particle model, because I bring him because he gives some examples of
Okay.
how. Go
Will
ahead.
you unlock the door so I can get out now?
Oh
I told
boy,
them,
very
I told
good.
in the script the
He's
room
in the
that
other
you had
room.
me locked in.
Yeah,
Yeah,
yeah.
yeah.
That's the only way I could get him on here. But thank you so much, Dad. I appreciate that.
You're
So again, the idea here's an electrical engineer. He has his own model. He's using that model to make a prediction that he never saw in all of his career. The model made a prediction. He's seeing it. It's not predicted in a mainstream science or in engineering, and that's quite amazing. And he's an electrical engineer that says there's no charge, and that all this that is particles are moving, but they don't have the charge on top. So that's pretty good. I'm going to try to look at some of these comments. They've been sort of a lot of different, because it is sort of a here's one that I do know actually. Tanev, Seno Tanev says, "Hi Dave, you'd be amazed at how many critical thinkers and people opposing Einstein dogmas here in Russia." We have great Russian members of our group. They come to many of our conferences. I have an absolute respect. The MPA started in the early 1990s, and they actually had a conference in St. Petersburg, Russia, because there are so many great critical thinkers in Russia. So they're all over the world. In fact, our database of all the critical thinkers are literally in 80 countries. If you go to db. Let's see if I have that. DB, do I have that anywhere? Yeah, here we go. If you go to this, db.naturalphilosophy.org, and you click on, you can see a map, and there's actually one, I think, by country. You can see how many people. Oh, there's nobody in my country that's a dissident thinker. Think again. We have them from almost every country and every continent except Antarctica. Alrighty, so let's take a look here. Is there anybody sitting in here that want to make? I do have the green room. I'm sorry. If you want to talk live with us, you can come to live.naturalphilosophy.org. We've got 20 minutes left. I know I see Ian, I see Stephen, Bob, I see James. Again, I'd rather try to keep to the subject today, talking about dissident science. If it's related in any way, that's of course totally welcome. Let's see if I have any. Let's see, positive physics and philosophy to that realization. And I'm looking through the comments. Anybody in the green room wave? Did I see them? Yes, no. I always bring Ian. Ian's there. Okay, Ian. The thing I like about Ian, he'll jump into anything. In fact, I'm going to add him here, and we're going to talk about women's wrestling. Okay, I'm just kidding. But anyways, Ian, I thought, what did you think? Because I know you've been involved here for many weeks. I mean, you guys have had absolutely astounding talks about charge, for instance, and those things. I mean, now you have literally, and I'm not here to challenge. I'm just giving you the facts. The newer minds today who are working on models, they're looking at charge as arbitrary, and that we have to explain that for some way in a Newtonian. Does that bother you, or because I know you guys talked about it. What's your thoughts on that?
Well, and I did volunteer, David, because I knew that if I didn't, you might press me, which is fine. No, maybe initially, it just raised the hackles a little. But on thinking about it a bit more deeply, I tend to think this, and I voiced this at the conferences, that I consider a lot of these models just helpful heuristically. I mean, I don't know if they have any ultimate reality, even atomic particles, even the sort of particles that we agree on, the pre-1930 particles.
Sure.
What is the reality? They're helpful in describing,
Yes.
the phenomena, and we can verify this physically and also mathematically. So, I probably wouldn't quite go as far as your father in saying there's no charge or it doesn't exist, or somebody like Bob Gray, who's with us here, who says there's no magnetic field. I would say these are concepts which are useful, but I don't know about ultimate reality.
Okay. So if I guess my question would be is if you think charge could be real, how would you, I mean, I guess the part with that I think all of us have who are making new models is like, if you have to give a physical reality, I mean, it seems to fit into that category that Alexander Unziker says, which isn't, like you said too, it's a convention. And I try to think to myself, I'm always open. I mean, the biggest critic of our own model, my father and I, is myself. Every time a new model comes out and someone has a crazy idea, I look at everything because you never know someone's onto something. But one of the things is I can't for the life of me come up with something that would say that charge is going to be ultimately something, because a movement caused by an attribute, it doesn't, where would the physicality come from?
Well, yes. I mean, those are very good questions, and we can speculate a lot on them. And there is danger in speculating because we're just perhaps voicing, prejudices or maybe justifications. But we do know that I suppose the early experiments on rubbing materials and getting electrostatic attraction between these different materials, we think of it in very, very elementary terms as rubbing the electrons away to get a positive body, and then the electrons is positive and the other one's negative, and they move together. But I mean, we do know there's something there, something more than mass. I mean, again, your father was talking about take away the charge and you get the gravitational interaction, and that's true. But I think somebody in the comment here said, well, what about and gravity? So
no, I think before you go on there, let me just clarify something. When he says you take away the positive negative, the gravity he's talking about is a gravity particle below the gravity particles that we have, what we consider to be gravity. So what it is you have particles that cause a gravity, like a Lesage gravity, around. That's what we see. That's what we feel. But when you get down to that level, they're a smaller particle, a faster than light speeds particle that is just a random particles going in random directions, but it's a different particle that lives in the same universe that is much, much, much smaller, much faster, that creates it. So I think that's one of the problems, I think, with even modern science is they're trying to give at the quantum level, take things that are up at this level. It's like, I'm going to explain the whole universe by moving basketballs. You're going to have a real problem at the atomic level, right? So I think that's one of the things that is another aspect of the models is you have to understand there are levels when people talk about gravity today. So gravity is a concept of, in this model, like particles moving in all directions, but there's the big ones are big G ones, and you have G2s, and then there's D3, and they're faster and faster and smaller. But the same idea exists, the concept exists. So I just wanted to clarify that. So I think people will think that our model says that the electron moves around it stays in orbit around the neutron. I'm using terminal terms because of regular gravity. No, it's a gravity of teeny weeny particles that are doing that. So I'm sorry to interrupt you. So.
That's fine, and I mean, all I think is that perhaps we don't disagree very fundamentally. We're just using different terms.
Sure.
You call it a term of microgravity or something, and well, I'm a bit with the conventional view. I'm happy to use charge, and the rate of flow of charge is current. But I mean, they are arbitrary. I do concede that. Arbitrary conventions.
Well, the other thing that happens too in these systems is they fail. And one of the things that they fail in my opinion, a lot of people are making the new models fail, is when you start to look at charges, and you start to look at charges in magnetic fields and electric fields, and you have all the mathematics for it. It gets really confusing really fast that you don't know what's causing what's being reacting from what. And I think that the younger generation of people making models today don't want that anymore. What they want to say is, give me a model for the electric field, give me a model for that particle, and I'll tell you how and why that interacts. And that's why they're using Newtonian physics. So as much as you're happy with it, the new generation isn't happy because it brings up so many paradoxes of, and that's what I hear a lot that's been discussed for the last couple of years here, is a moving charge in a field. And does that cause the field is the moving charge? And I think that ambiguity, which never seems to have an answer, is frustrating so much that the new generation, they're saying, no. The problem is we know there's forces there, like you said. We know there are things there, but we're going to have to finally buckle up and put our big boy shoes on and say, we now have to come up with a physical model for magnetism. And of course, Lionel Denis in 2008 showed the swirling particles like this made these things look identical to magnetism. So I think that's what I think is happening, Ian, that in these people's frustrations of seeing that the system that we have gets into these no-win situations where you can't figure it out. I think that's where that motivation is coming from.
Right, and I can see it, David, to a certain extent as being an attempt at unification. I mean, what you're describing is sort of perhaps using a gravitational model as the basis. Now,
our model has particles that move in random directions, that's gravitic. Particles that move in circles, that's magnetic. Particles move in straight lines, that's electric. And particles that move in groups, groups of particles that come at you in waves just like this, that's luminic. So no, our it's particles and forces, it's Newtonian. So it's not a gravitic only, it's gravitic, luminic, electric, and magnetic. And that's just all it is. All our model says it's the way particles move. It doesn't, you can, in our model, you can say the moon going around the Earth is a circle, and that can be considered magnetic, because if you get enough bodies around them and they have the Denis effect, that will cause, when they're going together, that causes attraction. When they're fighting each other, they fight and they'll go apart. So these things, again, I don't want to say, but you're characterizing this model as gravitic. It's not. It's basically particles move in space, and they move in patterns, and those patterns are what we call gravitic, or what we call that's what our model is. So it's not, whereas ether is a model that's mostly after light. People are looking to model light. So that this clarification.
Well, if I'd used the term Newtonian, you mightn't have dissented.
Newtonian it was, yeah.
Because, your father again said that the electrostatic force, could be conceived of in terms, and then you describe that in more detail yourself.
Right.
You call it Newtonian, but the basis of Newton's work, I suppose, was mechanical. I mean, we didn't have advances in electricity at the time, and so on. Other people would consider the other way around, I suppose, the basis of gravitational force to be electrostatic. And I don't know, you may have sympathy with that.
Oh, yeah, no. I know all about those. Yeah. In fact, if you look at a couple of things, you look at the electric universe, they're going to claim that the electric part of it is the dominating feature, and that gravity doesn't really exist. It's from the electric force. And that's a valid model. You have people who are etherists who say, and I think the reason people are etherists is because here's light, it's a wave, it's got to be a wave through something. We have to give it physicality, and that's what it is. The problem with, I think, an etherist, in my opinion, the reason I never became an etherist, I knew about ether way before my father came up with his wave-particle duality, where he made particles, not individual particles, but groups of particles into frequencies and coming at you in frequencies. Until he did that, I knew about ether, but there's just too many problems with ether in the way, you have lasers. How do you do ether theory? It's like, I'm going to send a beam of water, a beam through water to the other coast. You can't do it. So I think I think what happens, in my opinion, Ian, is that people will take an idea like electric, or people will take an idea like ether, and then they try to fit everything else into it. They're going to say, and that's what etherists do normally. I believe light's ether. Oh, now I got to describe gravity. For some reason, they think they have to describe gravity in ether. You know, that's the way I think people think. So when a person, people can look at a lattice. We had a guy on here, Alistair, I think his name was. He said the world is a lattice, and that light can be waves through those. You know who else was a lattice kind of theory? People don't know. Ron Hatch, the GPS guy, and he's a GPS guy, so he's looking at measuring things in space. That's his job. He became rich from that. But he said he came up in his mind sort of as a lattice theory. So we have these competing ideas, right? The lattice theory, and it's got to describe everything in the universe, light, gravity, all those things, lattice, people who think it's more electric. So yeah, I mean, absolutely. I know there are people out there, and right now everybody should be competing for them. So I'm going to try to bring some more people on.
Thank you.
You so much. I really appreciate
You're
you
very
guys
welcome.
coming
Thank
on.
you.
Okay. I know, I don't know who else is here. Ray Gallucci, do you have a microphone? And I see you in the green room. Are you there, Ray? No, he may not be able to speak. I know Steve Scully's there, Bob Gray, James Keene. If you guys want to come in and say something, that'll be great. Sort of raise your hand. I've got to scroll down if you do want to make any comments. Let's see, we are 10 minutes in. Let me go through the comments here. Here's a person, Steve Bryant. He will be talking with us. I'm glad he came by. He said he came by to say hello. He's one of the people I talked about, but he'll be coming on and talking about his disrupting physics and his tearing apart of the problems of relativity and his, what is it called? Oh boy, he's going to kill me because I know he has his own word for what he's replacing relativity with. But this is just sort of advertisement for talking with Steve coming up. So I see Steve Scully jumped on there. Did you want to say and talk with, come on and talk? Okay, well, we'll just say hello. Hey, Steve, how are you doing?
Good. How's it going?
Pretty good, pretty good. So, what do you think about all these dissonants out there with their ideas? I mean, I think one of the sad parts is why isn't this happening in universities?
Yeah, well, I mean, my thoughts on that is it's so far down that path that they're going to be the last ones to really realize that something's up.
They normally are, right? I mean, and it's funny because I tell people who have their own theories, said like, Steve, hey, you've got your own theory. Let's say the world adopts it. You're going to have people worshiping it and going off on directions it never should have. And then everybody's going to think that's all right. And then when it is wrong and people are trying to correct it, I said, it is a cycle that seems to go through. But I mean, yeah.
My thoughts are like the more we narrow in on an exact truth, the less like range of approximate interpretations there's going to be, because that's part of the problem is we're kind of like, this is approximately what's happening. Right. And so we have this like range of possibility, which then is interpreted all these different ways. But then once we have an exact truth that's so focused that it's hard to like, it's going to be much more of like a narrow path. So like from a perception of now, we'd look at like everyone, in my opinion, at some point we'll look at everyone in the future and be like, they all have the same belief system. But reality is there'll still be a huge spectrum in their experience of trying to find that truth, but they'll be much more fine-tuned than we are now.
Sure, I got you. But, yeah. So what you're saying, there's really a spectrum of, what we see as truths. I mean, we do see the way atoms and molecules go together, for example. Do we really know what's going on inside? Not very much. But, at each time we get more data, and that's one of the things about the Kuhn cycle. He's saying we get to a point where the standard model is just broken everywhere. I mean, we're lost. And what happens is we have so much data out there. And not only that, we all have information. I mean, Steve, you can go read. I mean, we have in our hands today, not only all of world knowledge today, but all of world knowledge that exists. That's like having the Alexander Library. The other thing is I thought was interesting, maybe we can talk about, would be I'm getting to the point, Steve, where this whole idea of being an expert or getting a degree in something, what does it mean if I can go and read about physics more and read about
Yeah.
more than those people in a university? Because, for instance, I have a friend in Brazil who was teaching his engineering students. You pick a subject like Big Bang, he required them to look outside and find critics of the Big Bang. He was eventually ousted from doing that. He's not ousted from the university. But it seems to me that we get this idea that one of the first things people ask me is, "Oh, do you have a PhD in physics?" And I'm
Mhm.
thinking to myself, No, and that's the reason I can criticize it, because if I did, I wouldn't be telling you all the problems. So
Yeah.
what do you think the future looks like for a university? I mean, what does it mean if we are if the next big physics advances don't come from university at all? What does that mean?
It means, well, to me, the thing is, there was a time there was no university, and then we started to have college, and people were just like, "This is higher knowledge," and
Right.
so to me, it's a reaction occurred to the point where it's an overreaction, and now it's
Right.
kind of abused. Like they raise their prices, they have
Right.
loan systems that make it so don't worry, you pay it later. It's always later, but
Right.
so that they can basically just siphon as much as possible off of the youth and really just like, which is part of the problem, that they're
Yeah, I know it's
actually
a problem. Yeah.
they're literally hamstringing us
Of
as we
course.
come out.
It's terrible. You know, it's funny.
For what? For
Yeah, you
false
just, yeah,
knowledge?
yeah, exactly. You
For
said something very
indoctrination?
interesting. I think what happens in education, you said something extremely interesting. I may just steal some of your ideas here. And that is, before we had universities, we had sort of libraries, and those were the places you could get people's past thoughts. We had to write it down because so if you, Steve Scully, had a great idea and it would advance technology and advance our understanding of the world, at that time we had to write it down. That was very expensive. Then Gutenberg came along and we
Mhm.
made those. And then we made universities so that we could actually help get that knowledge from these books from here into our
Yeah.
heads. And because not everybody had, you couldn't go to your right here and get every book. Now you can. So is
Mhm.
it the question of universities, except for obviously certain things where you need training? What there are certain things. I mean, unless you're like a surgeon or something, where you're going to go, I'm going to cut your head open. I'm not going to say, hey, Steve, I've studied surgery, so I know everything that's going on. There are some professions that need big telescopes
Yeah.
and all that stuff. So maybe that would go on. But there's a lot of things you don't need that
Yeah.
anymore.
It's just to me, I mean, this simply put is an overreaction on a
Right.
societal level. So just like getting hit in the knee and your leg trying to just reacts. I think it's much more just like we see that this is a means to have a better life, but then it becomes saturated and then oversaturated,
Yeah.
and then
Yeah.
the value is just gone. And then on top of that, it becomes more and more apparent that they're not really necessarily even bettering our
Sure.
circumstances. I mean,
Sure.
it's to the
Because
point where to
yeah.
me the future is going to be just so, first of all, the average person common knowledge is just going to increase
Of
in
course.
terms of
Yeah.
like on a fundamental level, where because the thing is it's not about knowing everything, it's about knowing how things are on like a fundamental level, which is
Right.
really just like the most limited thing, which is to me essentially. So I have a model, and I essentially conclude that all is one. There's this oneness, and that it itself arises from nothing. So kind of one of the things I point to in my work is that, well, science, the objective of science is to explain more with less, and then to explain the most with the least. But then the final step really of science is to explain everything with nothing. And that's really the
Sure.
key,
Yeah.
is that
Sure. Sure.
nothingness exists. And I'm going on a little tangent here. But
Sure.
from its exist, so like if you assume that nothing exists, and therefore it is also everything that exists, and so it has this in its nothingness, it is equal and opposite to itself because it's nothing and it's everything. And that's
Yeah, it
just
gets in. Yeah,
a
it's a philosophical
characteristic.
thing. Yeah, yeah, and I
That's
think
just how
yeah,
nothing is. It's
yeah,
eternally how nothing is. There's no changing that nothing is. If nothing exists, it's both everything and nothing. And so it has this duality that
sure,
just innately exists. And
yeah.
so it basically is like the perfect battery. There's no like loss over time, like a battery just over time degrades and doesn't functionally
Well, yeah, I think yeah.
work as
I
well.
I understand what you're saying, and we're gonna have to wrap up here soon. But I think one of the things that's interesting is if you look at Borchert's infinity, and if you believe infinity, that is, there is no ultimate particle. The reason I don't believe in an ultimate
Yeah,
particle
but that
personally,
arises
yeah, but it
from
rises
nothing,
from everything below it, though.
which is
And the thing is,
nothing at its
exactly,
core.
and if you keep looking for it, you'll find nothing. So it's really philosophically, you're going to have to accept some really strange things and just say, okay, let's try to at least understand what's going on around us. But listen, Steve,
Yeah,
thank you so much for coming
I,
on
I just want
and
to kind of
popping in.
Can I just add though that nothing and
Yeah,
everything though they're kind of like not really real. What's really real is the middle, the what comes
yeah.
between them, which is the oneness of all things. I just wanted to say that because that
Yeah. No, but in an infinite universe theory, that's sort of what way it works. Is that we
yeah
live in this sort of level here, and it's all controlled by we control and make things above us happen. You know, if our galaxies are creating a gravitational field at a huge level, it's trying, and everything we are a result of below, and that what you know what that. So there, the philosophical part of science is really important. So yeah, I understand what you're saying, but thank you so much, Steve, for coming on. I really appreciate people coming on. We are at noon now, and I want to thank everybody. I do want to put one more up here. This is Charles Lucas Jr. He is a person, Bill Lucas. You want to look up him and his work on our website. He did receive a Lifetime Achievement Award. If you are into the equations for force and unifying those, he is more on a mathematical side. Again, we support everybody's work, and he talked about the 13 electric and magnetic fields and other politically accepted theories can explain these properties, and he has something that he does try to explain that. So it's another person. There's just so many. I hope you really enjoyed today. Next week we're going to have our third in a series with Dr. James Maxlow. If you haven't seen it, I highly recommend you watch our videos both on dissident science and on the John Chappell Natural Philosophy side, CNPS. We have on our YouTube channels. Please take a look at those. Check us out and our websites, of course. This is sponsored by the Natural Philosophy Society, Natural Philosophy, John Chappell Natural Philosophy Society, and also by Dissident Science. You can check my work out at Dissident Science on YouTube. And I want to just thank everybody for participating, and we'll see you in the coming weeks. And if you have something you want to talk about and it's organized, you've been working on something, you can give a talk that's well organized, and you think that is something important for the community to take a look at. We're open. That's what Saturday mornings are here for. So again, I want to thank everybody for all of their support. I want to thank Franklin Hugh and the group that's been around here for many years. So if you're expecting to see him, I've given him some time off. Believe me, doing this every Saturday is a big commitment. So I want to thank them and all the subscribers. Keep on thinking. Like I said, I am David D. Hilster. I am your science therapist trying to get you to the promised land of becoming a critical thinker. Ciao for now.